All right, our second day of section 6.2 is on end behavior of a polynomial, and we also graphed some polynomials a little bit today. The end behavior is which way does the graph go as it goes off into infinity in one direction or the other. So the end behavior for an odd degree. The basic shape we're going to call is a snake. And that's because they end up going in opposite directions. So if it's an odd degree, that means it's like highest exponent is a 3 or a 5 or a 7. So when it's got a positive leading coefficient, so for example, if we have an equation like y equals positive 2x to the third power plus 3x squared minus 8. That would be an example of an odd degree with a positive leading coefficient. So it looks like this. If it's got a negative leading coefficient, an example would be like y equals negative 4x to the third plus 2x plus 10. So the leading coefficient is negative 4, so it is negative. Okay. When it's a positive coefficient, okay, f of x goes to positive infinity as x goes to positive infinity. So what this means, if you look at your x-axis, and I'm going to change colors here. Okay, look at the x-axis. 0 is in the middle, and then we have 1, 2, 3, 4, 5, and so on. And -1, -2, -3, -4, -5. So as we keep going up, 1, 2, 3, 4, 5, as we go way, way, way to the right, we end up getting up to the biggest number possible, which isn't really a number, it's an idea, it's positive infinity. And as you go left, you keep going left more and more and more, you end up going to negative infinity. So what this is saying is as you go to the right, so as x goes to positive, that means when you go to the right. So when your graph is going to the right, which way is the y going? Again, this is y. Y is going up to positive infinity. So again, if I pick a spot on my graph, as I follow that graph, let me put a highlighter. As I follow this graph to the right, I'm going to end up going up at the end. And as I follow the graph to the left, so I'm going left now, left, 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 I'm going to go down at the end. So it's going to negative infinity as x goes to negative infinity. So that means as you go left, the y is going down. So when you go left, y goes down. When you go to the right, y is going up. And this is up, and this is down for the y value. So just which way is the graph going? Left, or when it goes left, is it going up or down? When it goes to the right, is it going up or down? Okay, and then when the leading coefficient is negative, all that means is that when you go to the right, the graph ends up going down at the end. And when you go to the left, the graph goes up. So the blanks would be as you go to the right, so as x goes to positive infinity, the y value goes down. So y goes down as x goes to the right. And as x goes left, the y goes up to positive infinity. So negative infinity means you go left, the y is going up to positive infinity. So just see how those graphs are going different directions. That's why end behavior kind of matters here. Depending on the graph, the degree, and the leading coefficient, it could go in different directions. All right, when it is even, if it is an even degree, then the shape is called parabolic. What that means is the arrows will go in the same direction. So the leading coefficient is positive. That means y will go to positive infinity as x goes to positive infinity. So that means as x goes to the right, it goes up. And for this one, since they go in the same direction, as x goes to the left, it also goes up. So it's going up in both directions. And one example of this would be like y equals positive 6x to the fourth plus 3x to the third minus 8. The leading coefficient is 6 and the degree is 4. The second one, when the leading coefficient is negative. So what if we have something like negative 2x to the fourth minus 8? The leading coefficient is negative 2. So what that means is no matter which direction you go, your graph is going to be pointing down at the end. So if you go to the right, it points down. If it goes to the left, it points down. So left and right, they're both going down. And that's because the leading coefficient is negative. All right, so a couple graphs. If we want to graph the polynomial function, we're going to graph f of x equals negative x to the fourth plus 1. So if you look at the function, the degree is the biggest exponent. In this case, the degree is 4. And since 4 is even, the shape is going to be parabolic. What that means is the graph is going to be going up in both directions or down. Okay? So when we graph this, we're going to do an x and y table. So if you put in negative 2, that means f of negative 2 equals negative 2 to the fourth plus 1, which is negative 15. So we have negative 1, negative 15. And I apologize, we actually have to change the scale of our graph. We're going to go down by 2's. So negative 2, negative 4. So going by 2's on our graph. Okay. So if x is negative 2, y is negative 15. So negative 2, negative 15 is going to be like right here. Then what happens when you put in negative 1? So that means f of negative 1 equals negative 1 squared plus 1. And that will be 0. So x is negative 1, y is 0. So negative 1, 0 is right here. Then we put in 0. So f of 0 equals negative 0 to the fourth plus 1, which is 1. So 0, 1. If x is 1, plug in 1. Negative 1 to the fourth plus 1 is equal to 0. So 1, 0. And then if x is 2, we get negative 2 to the fourth plus 1. And that will give us negative 15. So positive 2, negative 15 is way down here. So this graph is going to be U-shaped. This is not a great line there. It's a little better. It's going to look like this. It's going to be both arrows going down. So even as we go to the right, it goes down. And as you go to the left, it goes down. So it's even. Fourth degree is even, which means the arrows will both go in the same direction. And since that leading coefficient is negative, that means it's going to go down. Negative leading coefficient goes down. And then we have one more graph on the note sheet here. So the degree of number 2 is the biggest exponent. The biggest exponent here is 3. So it's the third degree. This is odd, so the shape of this graph is going to be a snake. We know the shape is going to be a snake, which means it goes in opposite directions. It's going to go up in one direction, and it's going to go down in the other direction. Okay, and just a hint, if you look at the leading coefficient is positive. If it's a positive leading coefficient, that means it's going to go up as you go to the right. No matter what the degree is, if it's positive leading coefficient, the graph will be going up to the right. So if we make our table and plug in our numbers, so if it's -3, f of -3 is -3 to the third power plus 2 times -3 squared minus -3 plus 3. And yes, I always put parentheses around this to make sure that I don't make any mistakes. So now you can just take your calculator, type this in, you would get -3. Then we do the same thing for -2. F of -2 is -2 to the third power plus 2 times -2 squared minus -2 plus 3. So you type all in your calculator just how it looks. You'd end up getting 5. Okay, then we try plugging in -1. So f of -1 equals -1 to the third plus 2 times -1 squared minus -1 plus 3. So we plug in -1, we would get 5. Then we plug in 0. So we get 0 to the third plus 2 times 0 squared minus 0 plus 3. And we would get 3. Then you plug in +1, so f of +1 equals 1 to the third power plus 2 times 1 squared minus 1 plus 3. We will get 5. And lastly, you got to put in 2. So f of 2 equals 2 to the third plus 2 times 2 squared minus 2 plus 3. So you substitute in 2 for the x value, and you would get 17. And that one is going to run off our graph. But so when we put our points on here, the first points are -3, -3. Then we have -2, whoops, wrong thing there. -2, 5. Should be up here. Then we have -1, 5. So -1, 5 would be right here. 0, 3. 1, 5. And then lastly, we have 2, 17. So 2, 17 is going to be way up high. It's going to be way up here somewhere. So this graph is going to come up. It's going to curve and come down and curve again and go back up. So notice it's an odd degree, and it goes up to the right and down to the left. So odd degrees go in opposite direction. Up to the right, down to the left. Okay, and just want to point out, if it were a negative leading coefficient, the difference would be now your graph would look like this. Okay, that's the difference between positive or negative leading coefficient, and the odd degree tells you that it's going to go in opposite directions. And then one more comment to add on from yesterday. We talked about it in the notes the other day. Since the degree is 3, that means it changes direction 3 times. So it comes up, that's one direction, then it comes down, that's a second direction, and then it goes up again. So there's 3 changes in direction. Up, down, up. All right, and that's it for today.